Hi, and welcome to today's video tutorial. Today we're going to talk about linear equations. And in linear equations, we really have several different ways that we can write linear equations. And we're going to talk about examples of each one of those today. So first of all, let's look at the different ways we can write a linear equation. First of all, we have the one that you might be most familiar with, and that is slope-intercept form. Slope-intercept form is in the form y equals mx plus b. And of course, remember, m stands for slope, so m is slope, and the b is the y-intercept. The next one that we have is point-slope form, and point-slope form looks like this. It's y minus y1 equals m times x minus x1. Well, m is still slope, but in this case, x1 and y1 are referring to a point. So when we write the equation, we're going to replace x1 and y1 with the values from whatever point it is we are given in the directions of the problem. And the last one is standard form. Standard form is ax plus by equals c. And we'll talk about some different rules for standard form, and we'll write some equations in standard form in just a few minutes. So just one thing, a reminder, just remember slope formula is m equals y2 minus y1 over x2 minus x1. You might remember that is the change in y over the change in x, or you might remember it as rise over run. Okay, so first example, we are going to write the equation of each line in slope-intercept form using the given information. So we're going to start out with a real basic problem here. In problem A, slope is 2 and the y-intercept is -3. So if we're just using y equals mx plus b, we have all the information we need in order to write the equation. So using y equals mx plus b, remember this is m and this is b, so we can write it as y equals 2x minus 3, or, well, 2x plus a -3, or 2x minus 3. Okay, for b, slope is -1/2, and it goes through the point 0, 4. So remember, if we are given a point where the x value is 0, that happens to be the y-intercept. Because if you think about on a graph, an xy coordinate graph, where the graph crosses the y-axis is where the x value is equal to 0. So if you are given a point 0, something, that is always your y-intercept. So if they give you that, it's really easy to find the y-intercept. So our answer, of course, is y equals -1/2, just took the slope, -1/2 x plus 4, and we got the plus 4 from our points. Okay, example C goes through the points 2, -3, and 0, 5. So this time we have a little less information. We need to find the slope. So remember, y2 minus y1 over x2 minus x1. So y2, 5, minus y1, which is -3. 5 minus a -3 over 0 minus 2. So 5 minus a -3 over 0 minus 2. Well, that is 5 plus 3, which is 8, over -2. And 8 divided by -2 is -4. So now, and remember, this is our y-intercept again. So we have our y-intercept, we have our slope, we can write our equation, y equals -4x plus 5. Okay, and last example for slope-intercept form, it goes through these 2 points, 1, 6, and 8, -1. So once again, we have to find the slope of that line. So y2 minus y1, -1 minus 6, over 8 minus 1. So -1 minus 6 over 8 minus 1 is -7 over 7, which is -1. So our slope is -1. And this time we don't know what the y-intercept is, so we need to find it. So to do that, we can use either one of the 2 points. It doesn't matter which one, but we have an x value and we have a y value. So if we put that in for x and the y value in for y, we get 6 equals, and our slope was -1. So -1 times 1 plus b. Notice the only thing in this equation that we don't know now is the b value. So 6 equals negative 1 plus b, simply add 1 to both sides, and we get b equals 7. So now that we know the b value, we can write our equation, y equals negative 1x plus 7. Okay, so now we're going to use point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. So write the equation of the line in point slope form using the given information. So this time in A, we have slope is 1/4, and it goes through the point 5, 2. So remember, this is x1, y1 in our equation. So using y minus y1 equals m times x minus x1, we just plug in all of the values that we know, and we will have our equation. So y minus y1, well, y1 was 2, so y minus 2 equals, remember our slope was 1/4, times the quantity, so we do need parentheses around this, x minus x1, and x1 is 5, so I just put in the 5 there. So remember, x1 was 5, y1 was 2, and m is 1/4. Just plug it all in and we have our equation. Okay, next one. Goes through the points 6, 3, and negative 2, 4. So of course we don't have slope this time, so we need to find slope again. So y2 minus y1 over x2 minus x1. So 4 minus 3 over negative 2 minus 6. Well, 4 minus 3 is 1. Negative 2 minus 6 is negative 8. So our slope is negative 1/8. When we have a negative in the bottom or the top, we can just bring it out front. It doesn't matter. Okay, so now we have enough information to write our equation. So I'm going to pick one of those 2 points. It doesn't matter which one, but since we'd use this one for x1, y1, I'm going to go ahead and use that one anyway. So y minus 3 is equal to negative 1/8 times x minus 6. This was x1, this was y1. And so we have our equation. Okay, last we are going to use standard form. And remember, standard form is ax plus by equals c. So a couple of rules that we need to know about standard form. And depending on what book you look at and that sort of thing, some of them follow these rules, some of them don't. But as a general rule in math, we have a couple of rules for standard form. First rule is a, b, and c here should all be integers. So we shouldn't have any fractions in our equation. The other thing we need to know is a should be positive. So this number should be a positive value. If it's not, it's a simple thing to make it positive, and I'll show you how to do that in just a minute. So in example 3 here, write the equation of the line in standard form using the given information. So first, we're just given an equation in slope-intercept form. So all we have to do is change it algebraically so that it is in standard form. Okay, so notice we have a fraction here. Remember, we need to get rid of that fraction. So the easy way to get rid of a fraction is just to multiply everything through by the denominator of that fraction. So in this case, our denominator here is 3. So I'm going to multiply both sides of our equation by 3. And when we do that, we get 3y equals, okay, now we do need to use distributive property here. So when we multiply 2/3 times 3, we get 2x. And negative 5 times 3 is negative 15. And now we can subtract 2x from both sides so that we have ax plus by equals c. So negative 2x plus 3y equals negative 15. Now remember, I told you we can't have a negative a value, and in this case our a is negative 2, so we don't want to have that. So the simple trick to get rid of that negative sign is to multiply by negative 1, and when we multiply everything through by negative 1, all we do is change the sign of everything. So the sign here is negative. It's going to become positive 2x. The sign here is plus 3y. So when we multiply it by negative 1, it's going to be minus 3y. And the negative 15 on this side, when we multiply by negative 1, It's going to become positive 15. So it's a real simple task to change this a value from negative to positive. Change the sign of everything, and you're done. Okay, second example here. We are given 2 points this time, so we have to start from 2 points and write the entire equation. So what I'm going to suggest in this case is we're going to start with point slope form. So we'll write our equation in point slope form and then change that algebraically into standard form. Okay, so first, if we do that, we need to find our slope. So y2 minus y1 over x2 minus x1. So this time I used this as our x2, y2, and this is our x1, y1, just so that I have the bigger numbers and we're subtracting from them the smaller numbers. So y2 minus y1 is 11 minus 4. x2 minus x1 is 7 minus 2. So 11 minus 4 over 7 minus 2 is 7 over 5. So now choose one of those 2 points, once again, to write our point slope equation. Since these numbers are a little smaller, I'm going to use this point, and this was also the one that I used for x1, y1 anyway. So y minus y1, well, y1 was 4. So y minus 4 equals m, 7/5, times x minus 2. Okay, so remember, we can't have a fraction in standard form. So the easy way to get rid of that fraction is to multiply by the denominator, which is, in this case, 5. So we're going to get rid of the fraction. Multiply both sides by 5. When we do that on this side, we're going to use derivative property. So 5y minus 20 equals, now this side is a little tricky. The temptation here would be to multiply this 5 in through here, but we don't want to do that because remember, we have this number times this number times this number. And when we're multiplying 3 things together, we don't multiply one of those things by both other numbers. We multiply 2 of them together and then we multiply the other one into it. So we're just going to multiply these 2 numbers together. So 7/5 times 5 is just simply 7 times x minus 2. Okay? Now we can distribute the 7 into this set of parentheses. So 7x minus 14. Okay, so now we're almost there. Just move the 7x over by subtracting. And I'm going to do this all in one step. I'm going to go ahead and add the 20 over to the other side also. So we end up with negative 7x plus 5y equals negative 6. Negative 14 plus 20 is 6. Okay? And now, remember, we can't have this number being negative, so we just have to multiply through by negative 1. So multiplying, we get positive 7x. Negative 1 times 5y is minus 5y. And negative 1 times 6 is negative 6. So we end up with 7x minus 5y equals negative 6. And that's all there is to it. So hopefully you learned a little something today. And I'm sure that we'll be seeing each other again soon. Thank you for watching.